In this video, we are going to integrate using a trigonometric substitution. Question: evaluate the integral of 1 over x cubed times square root of x squared minus 9 dx. And the three basic trigonometric transformations available at our disposal are one with square root a squared minus x squared, one with square root a squared plus x squared, and one with square root x squared minus a squared. And it is clear that we are going to use this one, the one with square root of x squared minus a squared, and the substitution suggested is x equal a secant theta. So we have x squared minus a squared and 9. So a is 3. So this said, let's see what the substitution will give us. Let's call the integral I. Get I is 1 over kx cubed square root of x squared minus 9 dx. And we say set x to be 3 secant theta. And therefore, since we are doing a substitution, we need dx, and it means that dx is equal to the derivative of 3 secant theta is 3 secant theta tangent theta, because the derivative of secant is secant tangent, and d theta. Okay, so x cubed is going to be 3 cubed is 27 secant cubed, and square root of x squared minus 9 is square root of 3 secant, not 3, 9 secant square theta, because it's 3 secant theta all that square, which is 9 secant square theta. Okay. So square root of 9 secant square theta minus 9. Now, if you factor out 9 in the under the square, you get 9 secant square theta minus 9 secant square theta minus 1. Oh, recall that secant square theta minus 1 is tangent square theta. So this is equal to square root of, I should write it, square root of 9 tangent square theta. And that is 3 tangent theta. Perfect. So now this said, let's come back here and see what R becomes. R becomes integral of 1 over 27 secant cubed theta, secant cubed theta, and the square root of x squared minus 9 is 3 tangent theta. So that is our multiplication. And dx is what? Dx is 3 secant theta tangent theta and d theta. And what can cancel out? We have 3 and 3. We have tangent theta and tangent theta. And secant theta here, secant theta there becomes secant cubic theta becomes secant square theta, because x over x cubed is 1 over x squared. And now this form leads us to 1 over 27 integral of 1 over secant square theta d theta. Okay, in which these are the only things you were given to integrate. So that is I, 1 over 27. Okay, now the reciprocal of secant square is what? So secant is itself the reciprocal of cosine. So the reciprocal of secant square is cosine square. So cosine square theta d theta. If you don't see what I did, 1 over secant square theta is 1 over cosine square theta. That means 1 times cosine square theta divided by 1. And that is just cosine square theta. And how do we integrate this? We learn how to integrate trigonometric function, and there's no obvious answer for this, and that means we need a transformation, and we know also by in pre-calculus or trigonometry that cosine square is, so we have here 27. Integral of cosine square is 1 plus cosine 2 theta. Instead of squaring now, we use a half angle formula or double angle formula, whichever it is. Half angle formula in this case is 1 or 2 d theta. And that means I is equal to, okay, now move the denominator out, becomes 1 over 27 times 2, that means 1 over 54, okay, integral of, if you put this in brackets, 1 d theta plus integral of cosine 2 theta d theta. And with this, everything is easy to go. Okay? Now, we also know that the integral of cosine kx dx is, okay, the cosine is a derivative of sine. So the integral of cosine is sine. Now sine what? K theta. If you take the this, sorry, not theta, this x here. So x. If you take the derivative of sine kx, you get k cosine kx. So we have to divide by k, so that we have to come back to that plus constant. We want to use a constant term there. So k in this case 2. Therefore, I is equal to 1 over 54 brackets of parentheses theta plus k 1 over 2 sine of 2 theta, and all this plus constant. And now continue right into okay. Now to determine what we have here, if we want to go back to sine theta, sine 2 theta is sine theta cosine theta, 2 sine theta cosine theta. So this is just 1 over 54 theta plus 1 over 2 times 2 times sine theta cosine theta. That is to avoid any issue with the double angle that we have. So that means this is 1 over 54 theta plus sine theta cosine theta and plus constant. Now let's use a triangle here to determine what cosine theta and sine theta are. So this is theta, and we said that x is what's equal to 3 secant theta. It means that secant theta is x over 3. That means cosine theta is 3 over x. So this is x, this is 3, that is x, and this has to be square root of x squared minus 9. That means square root of hypotenuse square minus adjacent square. And that's a sine theta is equal to square root of x squared minus 9 opposite over hypotenuse over x, and cosine theta is, okay, 3 over x. Okay, and theta itself, theta, we say that x is equal to, that means secant theta, secant theta, secant theta is x over 3. It means that theta is secant inverse of x over 3. Therefore, coming back here, we do all the possible substitution. Integral of, we are given the equation is integral 1 over x cubed, 1 over x cubed, square root of x squared minus 9, and dx is equal to 1 over 54 parenthesis secant inverse of x over 3. Okay, then okay, now sine times cosine. So if you multiply these two plus 3 square root of x squared minus 9 divided by x squared. Okay, all this was constant. So I'm going to erase it because I can rewrite cosine that here to be 3 over x. Okay, so we have theta is equal to secant inverse x over 3. Okay, so now all we need here is plus constant. That's the final.